Hello students, we'll see clock frequency, machine cycles and instruction cycle. First of all, here I would like to clarify the machine cycle and instruction cycles are both the same. See, in some of the microcontroller they used to say machine cycle, and some of the microcontroller they use to say instruction cycle. So both are same, not they are not different. So the clock is microcontroller main starter and it is obtained from the external component called as a oscillator. It may be RC oscillator, it may be crystal oscillator, or we can give external clock pulse from the function generator. The clock rate is typically referred to as a frequency at which the clock generator of processor can generate the pulse. This pulse is used for the synchronization between the tasks of microcontroller. Higher the clock frequency means the faster the processor, and in many application faster is better. See, if you choose mostly in microcontroller datasheet they are given crystal frequencies value and clock frequencies value. So the clock frequency, if you will increase the clock frequency, it will decrease the time. We know the relation between the frequency and time. As you increase the frequency, time is get reduced. They are both are inversely proportional to each other. If I'll choose uh, crystal frequency of higher value, the time will it get reduced. The microcontroller will um, uh, react fastly, but it is also power consumption, it requires more power consumption. So clock from the oscillator enter the microcontroller via OC1 pin, where the internal circuit of microcontroller divide the clocks into four even clocks Q1, Q2, Q3 and Q4. So here this instruction is fetched by microcontroller at every first clock cycle, every first clock Q1. All the peripheral don't come with individual clock signals. So we require, if for example serial communication, we require baud rate to be set. So serial communication is inbuilt with microcontroller, but serial communication requires baud rate, and that baud rate calculation is totally depend upon the crystal oscillator. So the every time we have to no need to take a separate clock frequency for the baud rate generation. Then therefore four clocks makes up one instruction cycles during which one instruction is executed. These four cycles Q1, Q2, Q3, Q4 form one instruction cycle. In this one instruction cycle, the fetch, decode, process and store. These four process are happened during one instruction cycle. Once again, during one cycle they fetch instruction, decode that instruction, then process that instruction, and last one is store the value after processing. Then the supply voltage oscillator starts oscillating. As you power on, the oscillator starts to oscillating. The length of instruction cycle is depend upon the frequency of oscillators connected to microcontroller. If you use lower or less value of crystal, it takes time to instruction cycle to execute. The more it will take a more time to execute one instruction. We'll see how to calculate the time for one instruction. Again sampling, for example here I would like to give some example. Sampling rate of ADC, baud rate of your UART, then the rate at which timer, So these are directly tied up with your systems, and these all the peripherals require synchronization as well as clock signals. So it is not possible to give individual clock cycle. So microcontroller gives the synchronization and clock signal to this each peripherals. Then calculation of time required to execute one instruction. In datasheet they are given crystal frequencies value so and so range. For example, in peak 18 they are given 4 to 40 megahertz or 4 to 10 megahertz. It depend upon the version, which version you are going to choose. So here I have taken one example of crystal frequency with 4 megahertz. What I say, it is internal clock frequency. It use the internal clock frequency. The internal clock frequency. So in one instruction cycles, how many steps are there? 4 steps are there. So 4 megahertz is divided into 4. So it gives the 1 megahertz. We know the relation between the time and the frequency. Time is equal to 1 upon crystal frequency, which gives 1 microseconds. So for one machine cycle, it takes 1 microseconds. So some instructions are with one machine cycle, some instructions are come with two machine cycles. So some instruction like a move WF, it requires only one instruction machine cycle. So this instruction will execute in within one machine cycle. So the execution time for this instruction is required 1 microsecond. If you choose a higher crystal frequency, for example 10 megahertz, the time will get reduced and reduced. So some instruction comes with the 2 bytes. For example, like beat addressable BTFSS. These are the beat addressable instruction. This requires 2 machine cycle. So that time the 2 machine cycle into time is 1 microsecond, so it requires a 2 microseconds time. If I choose a 10 megahertz, then 10 megahertz divided by 4, how much it will be? So you calculate, student. Thank you, student.